Now we'll discuss the fundamental theorem of calculus. So there's two parts to this theorem. Part 1 says that if we have a continuous function on an interval ab, then the area function is given by a of x equal to the integral from a to x f of t dt will be continuous on the interval and differentiable on the interval. So this also tells us that the area function satisfies the equation that a prime of x is equal to d dx of a to x f of t dt, which is equal to f of x. So the area function is the antiderivative of f. For example, we want to simplify this. Basically, all we have to do is replace all of the x's with a t. So we get x squared plus the square root of x minus 2 plus 8 over x. One more example. We want to do the same basic thing. Everything's going to cancel out. We just have to change the t's to x's. So we have e to the x squared plus 3 times cosine 7x minus 4. So this is what the first part of the fundamental theorem tells us. However, what we usually use is the second part. This says if we have a continuous function over the interval a to b, and that capital F is any antiderivative of f over the interval a to b, then the integral from a to b of f of x dx is equal to capital F of b minus capital F of a. So this actually lets us evaluate these definite integrals. For example, let's evaluate this one. So we start by actually finding the antiderivative. We add 1 to the exponent and then divide by that number. So I have 1 over 5 t to the 5th minus t cubed plus 7t. We're going to evaluate this between 1 and 6. So we start by evaluating at 6. This is 1 over 5 times 6 to the 5th minus 6 cubed plus 7 times 6. And then we subtract, evaluating at the lower limit. So minus 1 over 5, 1 to the 5th, minus 1 cubed plus 7 times 1. And once we evaluate this, we get 1, 3, 7, 5. Let's do a couple of more examples. So this time, I want to find the integral of the square root of t plus et dt from 0 to 8. So we start with the integral. Remember that a square root is a 1/2 power. So when I add 1 to 1/2, I get 3 over 2. And then I want to divide by that. So this is 2/3 t to the 3 over 2 plus the integral of et is just e to the t. And then we're going to evaluate this between 0 and 8. So now I have 2/3 8 to the 3 over t plus e to the 8, and then we subtract the lower limit. So minus 2/3 times 0 to the 3/2 plus e to the 0. Once you evaluate this, this is approximately 2,995.04. Here we're going to do some trig functions. So we know that the derivative of cosine is negative sine, which means the integral of sine will be negative cosine. The derivative of sine is cosine, so the integral of cosine is sine. And the derivative of tangent is secant squared, so this will be minus tangent t. And we'll evaluate this between 0 and pi. So this is negative cosine of pi plus sine pi minus tangent pi. And then we'll subtract evaluating this at 0. So minus negative cosine of 0 plus sine of 0 minus tangent of 0. And once you evaluate this, you get 2. We'll do one final one. Here we want to find the area under the curve f of x equal to 3 minus the absolute value of x between x equal to negative 4 and x equal to 2. So we know that this is the integral of negative 4 to 2 of 3 minus the absolute value of x dx. So you may not know how to take the integral of the absolute value. However, we do know how to take the integral of x. So we're going to break it up in terms of x. So we'll have the integral from negative 4 to 0 of 3. Whenever we take the absolute value of a negative number, we have to change the sign. So we'll make this 3 plus x dx. We'll then look at the positive side, the integral from 0 to 2. The absolute value of a positive number is just itself, so nothing changes. So now I have 3x plus 1/2 x squared. And we'll evaluate that between negative 4 and 0 plus 3x minus 1/2 x squared between 0 and 2. So here I have 3 times 0 plus 1/2 times 0 squared minus 3 times negative 4 plus 1/2 times negative 4 squared. Then we look at the other side, so plus 3 times 2 minus 1/2 2 squared minus 3 times 0 minus 1/2 0 squared. And when you evaluate this, you get that the area under the curve is 8.